so annoyed because like, I usually build up to that, but like now I have, during like a holiday, it's like, well, now I have a whole week to do I don't know what except just go back through the things we already did. And I
Right.
find that boring after a while.
Right, right. Yes, that's true. I know you guys are actually on the good days this semester. This semester they added in the Cesar Chavez holiday on Monday the 1st, April 1st. So that cut into the Monday, Wednesday, um, you know, teaching days. And then we had, the first day of class, first day of this semester is a holiday, Martin Luther King, and that's always been. And then, oh, and then the other one is April 8th is the solar eclipse. And so they're I guess our campus is like one of the main places that people are going to gather. And so they're telling us don't even have class that day. Just either do Zoom, do it remote, give an assignment, and they can do it at home, that kind of thing. They don't want a bunch of students on campus that day. So that's another Monday. So that's 3 Mondays. And you think, oh, it's only three, but when you're teaching, taking 3 Mondays out of the teaching semester, it's a lot,
Yeah.
especially with, we don't get to cut back on what we have to teach. We still have to do it all. So anyway, all right. Well, you guys are here. Yay. So we're going to finish up. This might be a shorter day today. We're going to finish up the 10.3. So this week I just sent out an announcement. And so you guys have homework 6, homework 7, and quiz 4 due Monday. So just kind of keep that in mind. Make sure you give yourself enough time to really dig deep and figure out which assignments, which concepts are you struggling with, which ones do you just need more time on, because sometimes that's all it takes is just a little bit more time to really understand the material. The biggest thing that I would say in chapter 10 is knowing which rule to use for which formula. Okay, so what I'm going to do is, and I really do try to not Kahoot you to death. I just started using this this semester. I've done it in the past, but this semester I've made a few more. So I promise I'm not going to Kahoot you to death, but this is one chapter that really kind of lends itself to, I gotta share my screen here, lends itself to Kahoot. So we're gonna try one more. So go ahead and either do the QR code or go to kahoot.it and then put in that pin and I'll wait for you. So this one is only based on the four special rules. So e to the x, ln of x, b raised to the x power, and log. So if you want, go ahead and pull up the formula sheet. I would definitely get used to using that formula sheet or the one that we did on Tuesday with the 4 special rules in it. So I'll wait till everyone gets in. And let's see how many you are here. So there should be 10 of you up there, so I'll wait. I love the icons. I think they're so funny. And I love that you don't get to pick them. You just are, it's the luck of the draw. Okay, so I'm waiting for, I think, 3 more of you. Let's see, who do we need? Gabriel, you need, no, Gabriel's not here yet, I don't think. Um, Evan's here, Orlin, Janara, Janaro, Matthew's here. George, we're waiting on you. Mahmood, we're waiting on you. Dylan's here. Brian, we're
Sorry,
waiting on you. And Adam's here.
Miss. I was able to get in, but I'm not showing up. Like I'm trying to join back, but it says my name is already in you.
Oh, huh. And did you type in your name?
Yes, ma'am.
Huh. That's weird. Usually it pops right up. Can you get out and then come back in?
Yeah, I'm trying right now. It's asking me for the pin again.
Okay. Thank you. There you are. Okay, there's more. Yep, Lauren, I see you're there. Okay, there. Is that you, Jay? Is that you, George?
Yes.
Okay, perfect. All right, so here we go. And Javier, there you are. Okay, so again, this is the 4 special products. So that's the only thing. So what I want you to do, and what I would love is to have 100% everyone's right on the same one. I did this in class yesterday, and there was only one, there's 8 slides. There was only one slide that we got 100% right. So just some hints, make sure that you look at, if there's an LN, look for the LN one. If there's an E, look for the E one. If there's log LOG, look for that. And then if it's a exponential function where you have a base raised to the x power. And so remember the exponent is where the variable is. So just those are just some hints to know which one to look for. Okay, here we go. And then for those of you who just came in, the pin will show up at the bottom. It should. And this should go fairly fast. There you go. There's the pin if you just joined us. Wow. Okay. So with this one, you only have 10 seconds. I'm trying to make it go really, really fast for you. So you only have 10 seconds. So there's only 6 of you that actually answered, and it was across the board. Okay, so here is what I mean when I say look for certain things. So you see how there's an LN right here? Let me get my pin here. An LN right here. It's not going to let me write on it. So the red is the one that has LN. So that's how you know which one to use. So remember, we're not looking for the inverse. And I think that's why the e to the x gets picked. We're not looking for the inverse. We're looking for the derivative. So if it starts with an ln, it's going to end, or it's going to be the derivative that starts with the ln. Okay. And then, yeah, so the gold, I guess it is, that one is when you have a base, so a number raised to the x power. That's the only time you'll use that one. Okay, here we go. So again, you only have 10 seconds to answer. So which one will you use? Which rule will you use? Okay, that's better. That's much better. So again, do you see how there's an e to the x? That's how you know, okay, I have e to the x, so I'm going to use that function. Okay, The red is ln, so there's no ln there. The orange is, or not orange, whatever that is, gold is b raised to the x power. But because there's e, you're going to use the blue one. And then the green one is you only use that when you see the term log, L-O-G. That's the only time you'll use that one. Okay? Any questions on that one? And then we're going to go through and actually find the derivatives of those. Okay, Jay's still on top. Dylan's close behind. So again, remember, it's how fast you answer and if you got it correct. Okay, yay, 100%, yes. So anytime you see log, you know you're going to use the green one, the log base b of x. Very good. Okay, we're getting there. Okay. We just came up on the screen. Okay, so again, the gold one, because the 3 is your base, so think of the b in this function as the base. So b is your base, so 3 is your base raised to the x power, so it's the gold one, right? So again, the red one is only if you see an ln, the blue one is only if you see an e, and then nobody picked log, so that's good. Okay, so really pay attention to the pattern of it. Uh-oh, Dylan, you dropped out. Here's the next one. Okay, very good. So e to the x, again, anytime you see e raised to the x power, you're going to use that function e to the x. The derivative is e to the x. So again, the only time you're going to use the ln one is when you actually see the ln in the question. Okay, that's the only time you'll use that one. Okay, Jay still on top. 3 more. Okay, very good. So ln, you use the ln one. Very good. And again, the e is, or the green one is the log. So the only time you'll use the log one is if it says log, lon, or log. The ln is the natural log, and the base on that is e, where the log can have different bases. So the only base in ln is the base e. Log, you can have different bases. Okay. Jay's still on top. Good job. Perfect. Okay, saw the log, so you know you're going to use log. Excellent. Okay, and then the last one. Okay, very good. So again, the majority picked the right one. So this is the base is 7 raised to the x power. So the gold one is the base b raised to the x power. So again, ln wasn't there, so you wouldn't use the ln one, the red one. E wasn't there, so you would not use the e one. And nobody picked the log one. Good. Okay. So again, it's just knowing when to use which one. So we'll see who, Mahmoud, third place, Matthew, second place, nice job, and first place, I think it was George. Yep. Okay, excellent. All right, you guys. So with these, just keep practicing knowing when to use which one. So I'm going to stop sharing. Oops. That, stop share. Okay, so talk to me. What was the hardest part about those four? Like, what's confusing about those? Or is there anything confusing about those?
I just get confused on LN and log, but it's fine. I got it.
Okay, so you got it now. So the ln is always base E. Log is all the other bases, base 10, base 5, base 2, whatever it is. So that the log can change the base depending on what number is there. ln is always base E. Okay, anything else? Are you able to see, for instance, when get a whiteboard here, when you're writing, so if you have this one, right, are you able to see, sorry, Katie, that our base, it doesn't matter what the base is, if the exponent is an x, sorry. Sorry. Okay, so when the x is the variable, that's when you're going to use this one. Okay. If you have log base, whatever it is, so it doesn't matter what the base is, it can all change, right? It can change. Then you're going to use the log function. And then the ln of x, this is always base E. So again, we're not finding the inverse because ln of x and e raised to the x, these are inverse operations. So we're not finding the inverse, we're just finding the derivative. So if you see an ln, then you know you're going to use the ln one. These here are also inverses. And so you just want to make sure that you can identify which one goes with which function. Okay? All right, so what we're going to do today is we are going to jump into our the last problem. I'm trying to find the right thing here. The last problem for our quotient and product rule. Okay, so before we get started on that, what I wanted to do is just kind of walk through the product rule one more time, because the quotient rule is super common. It's very, there's only two differences with the quotient rule. So what I wanted to show you though is in your My Math Lab. So when you use the, excuse me, view an example, they write it a little bit differently than what I gave it to you as. And there was a reason why I gave it to you the way that I did. So in My Math Lab, they write it as the first times the derivative of the second plus the second times the derivative of the first. Okay, that's your product rule. Well, in the notation that I gave you, oops, oh, what happened to it? Oh, that's the whiteboard. In the notation that I gave you, I write it as the derivative of the first times the second plus the first times the derivative of the second. When there's a plus sign, it doesn't really matter which order I put this in. So for instance, if I go back to numbers, if I said 2 times 3 plus 3 times 2, right? It doesn't matter which way I put the numbers. It's going to be the same. That's with the plus sign. Where it differs is when there's a minus sign. And that's why I do it the way that I do it here and not exactly the way in My Math Lab, because when we go to the quotient rule, the top is exactly the same setup, just with a minus sign. And then we have to put it over the second one squared. So I wanted just to show that to you. Again, I'll show you in my math lab what it looks like. It's the exact same thing. Nothing's different. They just flip-flop these two. We have them, let me write it right underneath it.
Miss, are you writing on the screen? Because I can't
Not
see.
yet.
Oh, okay.
Oh, you know why? It's because, hang on a minute. It's because it's at the whiteboard. Hang on, I don't want the whiteboard. There we go. Okay. There we go. All right. So this is what the My Math Lab has it. I have it written as the derivative of the first times the second plus the first times the derivative of the second. Do you see how it's exactly the same thing? They just flip-flop these two, is all. All right. So I just wanted to point that out to you, that yes, there is a little bit of a difference in how they show view an example, but it's exactly the same thing. So don't panic when you see that. All right. If you use the one that I'm showing you, then when we get to the quotient rule, there's no difference. The quotient rule is exactly the same thing. Okay, same setup, I should say, same setup. Okay, so here we go. What I'm going to do, I'm going to move this over, and we're going to try one, just the product rule. Okay, so, wow, why am I struggling today? Okay, so given f of x equals, let's say 5x cubed times e to the x. Okay, I want you to find f prime of x. So in other words, I want you to find the derivative. Okay, so remember with the product rule, you're going to go through all the four, you're going to get 4 cast of characters because you need those 4 parts. And then you're just going to put those parts in the correct formula. Okay, so go through and get your 4 cast of characters first. And I'm going to give you time to do it. And then I want you to write in the chat, write your answer. Show me, or yeah, type in your answer in the chat once you get it. So I'll get you started. So you're going to find the first and the derivative of the first. Then you're going to find the second and the derivative of the second. So do those 4 first. And then you can plug them in. Okay, so I'm gonna write on the screen, but you guys just keep going. And then just kind of check to make sure that yours is matching mine. Okay, so those are your 4 cast of characters. So the first is 5x cubed, the second is e to the x, and then the derivative of the first, right? You're using the power rule, so 15x squared, and then the derivative of e to the x is just e to the x. Okay, so now we're just going to plug it into our, think of it as a formula, right? You're just putting it into the formula. So the derivative is the derivative of this first times the second plus the first times the derivative of the second. Okay, so this is where my math lab's going to catch you. This is a perfectly good answer. right? You have all the parts, you have the forecasted characters, they're in the right spot. When you're doing MyMathLab, it's going to ask you to simplify this. Okay, so what that means is you have to get your greatest common factor. So the e to the x is easy, right? Everybody sees e to the x. What about the 15x squared and the 5x cubed? What's in common between those two terms?
Between the what? I'm sorry.
What's in common between 15x squared and 5x cubed?
5x squared.
5x squared, perfect. Okay, so what you're doing is you're factoring out what's in common, and then what's left, so 15x squared divided by 5x squared is 3, and the e to the x cancels, and then 5x cubed divided by 5x squared is just x, and the e to the x cancels. So this is what MyMathLab is going to look for. If you type in this one, it's not wrong, it's just not simplified. And so MyMathLab will mark it wrong. So make sure that you notice when you can factor out a greatest common factor. And that's going to be your MyMathLab answer. Okay, now the difference is on the test that I give you, and our next test is coming, when is it? Thursday, March 7th is our next test. So that's the week right before Easter break. So we just have a few more weeks. If this was a test question, this answer right here would be great. You'd get full credit. Because all I'm looking for is, do you have the forecasted characters and did you put them in the right spot? That's what I'm looking for. If you can do this and simplify it, I'll give you extra credit. Okay, so that's how you'll earn extra credit on this next test, is being able to simplify it. But this answer right here is a great answer. It's just not good enough in MyMathLab. So MyMathLab is going to make you practice getting that extra credit, which is actually good. Okay, so any questions on the product rule? Okay, so now we're going to move to the quotient rule. So the quotient rule is right here, and I'll rewrite it so that we have it in front of us. The quotient rule, notice it's the exact same setup, but with one difference. It's a minus sign, which makes sense, right? The product rule is multiplying, we add. The quotient rule is dividing, we subtract. So they're opposites, and that's on purpose. Then the only other difference is now we're dividing it by the second one squared. So you're still going to get your forecasted characters. Even with the quotient rule, you're going to do your forecasted characters. You're going to plug your casted characters in the right spot, and then you're going to divide it by the second one squared. So in MyMathLab, it shows it as the top and the bottom. The top and the bottom. Okay, I'm still showing it as the first and the second. So that's going to be a little bit different in MyMathLab, but it means the same thing. So I like to keep it as simple as possible. If you've memorized or you know how to do the product rule, the quotient rule is going to be just as easy. Okay, it's just knowing the top is the first one and the bottom is the second one. Okay, and then I'll rewrite this so that you can still see it here. All right, so we have given the first divided by the second, the derivative. So this is the quotient rule, because we're dividing, right? Quotient is the answer to a division problem, is you take the derivative of the first times the second minus the first times the derivative of the second all over the second one squared. Okay? So that's your formula. You're just going to plug it in and work it out. Now, as you will see, using the quotient rule is a lot of work. right? Just like using the product rule is a lot of work. So we're going to start number 6, and we're going to do using the quotient rule. Okay, so the quotient rule says I have to get my forecasted characters. So I'm going to do that first. So the top one, or the first one, is 11x to the 4th minus 9x to the 3rd. The derivative of that is 44x to the 3rd minus 27x squared. Everyone okay with that? Just use the power rule. Drop the 4 to the front and multiply, subtract 1. Drop the 3 to the front and multiply, and then subtract 1. Now I'm going to get my second one. So the second one is x squared. The derivative of the second one is 2x. Again, drop the 2 to the front and subtract 1. Okay, now I have my forecasted characters. Now I'm just going to plug it into this formula. Okay, so I have, I'm going to run out of room real quick. Hang on. I have to do it over here. Okay, so I have derivative of the first. And notice anytime I have a binomial, trinomial, whatever it is, I'm going to put it in parentheses, because what that does is it reminds me that this is one unit. That 44x cubed minus 27x squared is one unit. It stays together. Okay, and then I'm going to multiply that by the second minus the first times the derivative of the second, all over the second one squared. All right, now here's the good news. Obviously, the bottom is going to be super easy to simplify, right? Where all your work happens is in the top. That's where all the work happens, right? Because you have to simplify that on the top. Okay, so here we go. Scroll this down. So I'm going to distribute this x squared through. So I get 44 x to the 5th. I like the pen thinner. Hang on a minute. Okay, so I have 44 x to the 5th. Okay, all I'm doing is I'm distributing and multiplying, and then distributing and multiplying. Minus 27 x to the 4th. Okay, now here is where people get caught because of this minus sign. So I can move this 2x to the front, and it makes it a little bit easier to multiply. So I have negative 2x times 11x to the 4th, which is a negative 22x to the 4th. And then negative 2x times a negative 9x cubed is plus 18x to the 4th. This should be the 5th here. So 2x times 11x to the 4th is 22x to the 5th. And then a negative 2x times a negative 9x cubed is positive 18x to the 4th. Okay, and just moving this one to the front just allows me to use that negative, and I won't forget it. If I forget it, then it's going to change the signs on everything. And then I put that over x to the 4th. Okay, because I'm using the power rule of exponents. All right, now I'm just going to combine like terms. So 44x to the 5th minus 22x to the 5th is 22x to the 5th. Negative 27x to the 4th plus 18x to the 4th is a negative 9x to the 4th over x to the 4th. Okay, one more step. Now I can simplify. 22x to the 5th divided by x to the 4th is just 22x. 9x to the negative 9x to the 4th divided by x to the 4th is just negative 9. Okay, and that is the quotient rule. That's my derivative. Okay, do you see how much work that is? Tons and tons and tons of work. Sometimes you just have to do the quotient rule, but other times you can get out of it. So if you can get out of it, remember, it's the whole idea of if you're a good math mind, you do math smarter, not harder, right? So if I do this without the quotient rule, the only time I can do this without the quotient rule is if I have a monomial in the bottom, one term in the bottom, because I can simplify this first, right? 11x to the fourth divided by x squared is 11x squared. Negative 9x cubed divided by x squared is negative 9x. All I've done is I've simplified this. Okay, now I can just use my power rule. Drop this to the front and I get 22x. Negative 9x becomes negative 9. So much faster. Same answer. 22x minus 9. Same exact answer. But look how much more work that quotient rule was. Right? So look for it. If you can get out of it, do it. The only way you can get out of it is if it's a single term on the bottom, and then you just divide that term into each top term. Okay? But there's also going to be times where you can't get out of it. You just have to use the quotient rule. Okay? If there's a binomial on top and a binomial on the bottom, you can't get out of it. If there's a single term on top and a trinomial on the bottom, you can't get out of it. You have to actually do it. Okay? So it will get faster for you. It does get faster. Just take the time to write out your forecasted characters. So the top is my first, 3x minus 1. Derivative of 3x is just 3, and the 1 goes to 0. The bottom is my second one, 5x squared minus 3x, and then the derivative of that is 10x minus 3. What I'm hoping is that your power rule skills are really coming along. Right? You should never even have to think twice about the power rule anymore. Remember, when it's a constant like that minus 1, it just goes to 0. When there is a x to the first power, that gets dropped off, that x gets dropped off, and the derivative is the number. So 3 here, 3 here. That's why the x goes away. Okay, and now I just plug it into my quotient rule. So derivative of the first times the second minus the first times the derivative of the second. So notice, if it is a binomial, I am definitely putting it in parentheses. And then all over the second one squared. Okay, now here's a really good example. On that first one, we actually simplified the second one, right? We did x to the x squared squared, so we got x to the fourth. Here, I don't have to do that. Just leave the bottom alone. You don't ever have to fix the bottom. You don't have to multiply it out. All I want you to do is to fix the top. Okay, so the top, I'm going to distribute through. We're going to skip this one, so I'm going to use this. We're going to distribute this through. I definitely need to redo these and make more room. So I distributed 3 times 5x squared and 3 times negative 3x. And then here, I'm just going to have to FOIL. So here's what I suggest. Use this minus sign after you're done FOILing. 3x times 10x is 30x squared. 3x times negative 3 is negative 9x. Negative 1 times 10 is negative 10x. And negative 1 times negative 3 is plus 3. Now push that negative through. Okay? Because if you lose this, that all of your signs are gonna be wrong. So hang on to that negative do your multiplication, and then push that through. And then all over 5x squared minus 3x squared. Separate this. Okay. So now I'm just going to add my like terms. So I'm going to push this negative through. This becomes a plus. That means everything inside changes. Okay. All I did is I just pushed that negative through. So now I'm just going to add my like terms. So 15x squared minus 30x squared is a negative 15x squared. Negative 9x plus 9x, those go away. So I end up with plus 10x minus 3 all over the bottom squared. And that is my derivative. Clean it up here. Okay, so it's negative 15x squared plus 10x minus 3 all over the second one squared. And sometimes it cleans up really nicely. Sometimes it's kind of a bigger function. Okay, any questions on that? It's definitely an exercise in keeping organized, getting your forecast of characters, keeping it all in the right spot, putting them all in the right spot, and then distributing, adding like terms, and simplifying. So it's definitely an exercise in algebra. Lots of algebra there. Okay, so this last one, and then I'm going to have you guys practice a couple, and then we'll call it a day. So this last one is one of the word problems that you'll see. And so according to economic theory, the supply X of a quantity in a free market increases as the price P increases. Okay, so that's a theory. As the supply increases, the price increases. Suppose that the number X of DVD players a retail chain is willing to sell per week at a price of P is given. So there's your function. So notice it's a quotient. You got to use the quotient rule. You can't get out of it. This part right here is just an indicator that we're only looking at a price between $10 and $70. Always notice with these word problems, always notice what your variables represent. The P represents the price, and the X represents the number of DVD players. That is key to doing these word problems, is what does the variable represent? Okay, so it's asking us to determine dx dp. So here's what this means. Remember, dx dp is just a notation for a derivative. So it's saying determine the derivative. But here's what this means, because when we get into related rates, you have to understand what this means. So remember, derivative is just the change. So it's asking for how is the number of DVD players changing based on the price? Does it increase? Does it decrease? Okay, so it's how does the number of DVD players change based on the price? So the derivative of X in terms of P, the derivative of X in terms of the price. That's what this is asking. That's what this is asking. Okay, so we got to find the derivative. It's a quotient, so we're going to use our forecast of characters. So the first is 100p. Derivative of the first is 100. The second one is 0.1p plus 1. So the derivative of the second is just 0.1. Okay, so here we go. Derivative of the first times the second minus the first times the derivative of the second, all over the second one squared. Okay, so now I'm just going to clean it up. So 100 times 0.1p is 10p. 100 times 1 is 100. 100p times 0.1 is a negative 10p. Well, look what happens. The top goes away, right? The 10p and the negative 10p go away. So I end up with 100 over 0.1p plus 1 squared. Okay, so that is our derivative. So the derivative is 100 over 0.1p plus 1 squared. And notice again, all I did is I just cleaned up the top. I didn't even bother with the bottom part. I just left it. Okay, so now here is where knowing what your variables represent will help you in answering the question. So in B, it says, find the supply and the instantaneous rate of change of supply with respect to price when the price is $40. Okay, so instantaneous rate of change, that's your derivative, which we already got right here. 40 is our P. That's our dollars, right? That's our price. So all we have to do is use our derivative and plug in 40. Oops, plug in 40. So 1 times 40, calculator out, or 0.1, sorry. Plus 1. So 1.1 times 40 plus 1 is 5 squared. So 100 over 25 is 4. Okay, so what does this mean? So what we found is how our supply is changing based on the price. Okay, how the supply is changing based on the price. So the interpretation of this answer, let me type it over here and then I'll slide it over. So the interpretation is our supply increases by 4 when the price is $40. Okay, so that's that idea of our instantaneous rate of change. At the price of $40, our supply is increasing by 4. Okay? Now let's try it with 41. So we've already done all the work. We already have the derivative, right? So now we're going to find our derivative at 41. So we do the exact same thing. 0.1 times 41 plus 1, and that whole thing squared. So 0.1 times 41 is 4.1 plus 1 is 5.1 squared. Which is 3.844. So 3.8, so not quite 4. So with this one, the interpretation is, let's see, when the price is $41, the supply increases by 3.8. So in other words, what happens is my supply starts slowing down the higher the price goes up. Okay, so the price does determine your supply. It determines how much your supply is increasing or decreasing. Okay, so any questions on those?
No. No.
Okay, so what I'm going to do is I'm going to put you guys in breakout rooms, and we're just going to do two. We're going to do one problem with the product rule and one problem with the quotient rule. We're going to start with the quotient rule one. So what I'm going to do is I'm going to copy and paste this Jamboard into each room. So if we'll just have 4 rooms. So let me open the rooms first. So you'll get an invite, and then I'll come into each room and give you the Jamboard that you need. So go ahead and go into each room. Couple more minutes for them to come back. I don't know if I gave you enough time or not, but we'll see how it goes. All right, so everybody's back yet. Hang on a sec. Okay. All right. So this was from room 2. So who was in room 2? Just kind of walk me through what you guys did on this one. And I'll write it on here. Who is room 2?
I was, but I kind of got lost.
Okay. All right. So let's just kind of walk through this. So your first one, right, is the top one. So that's your x plus 2. So what's the derivative of x plus 2?
I mean, just the one.
Yeah, it's just 1. So remember, and for whatever reason, this is always the hardest one for people to use that power rule. Just remember, it's x to the first power, right? So the derivative of this is I drop this to the front, and then I subtract 1. Well, if I subtract 1, I get x to the 0. X to the 0 is just 1. So that's why it's just 1. So anytime you have x to the first power, it's always going to be the number sitting in front. The x just drops off. And the reason it drops off is because when you subtract 1, you get x to the 0 power, which is just 1. Okay, so there's your 1. And then the second one was x squared minus 1. So the derivative is 2x, right? So again, drop the 2 to the front, you subtract 1, and it goes x to the first power. Okay, so now it's a matter of just plugging in where it belongs. So we have the derivative of the first times the second minus the first times the derivative of the second, all over the second one squared. Okay, so we're good here. You don't have to do anything else on the bottom. You're good there. And on the top, you're just going to simplify it. So 1 times all of this is still x squared minus 1. And then we're going to distribute that negative through. So again, and I do it mentally. You can either physically move this to the front, or you can just do it mentally. So negative 2x times x is a negative 2x squared. Negative 2x times 2 is a negative 4x, all over the x squared minus 1 squared. Okay, and then it's just a matter of adding your like terms. So I see you have a negative out here. So x squared and a negative 2x, that's your negative x squared. But it would be a negative 4x. And then minus 1. So I think what happened when I look at this, when I look at here and here, it looks like that the negative didn't get pushed through. So with the quotient rule, this negative is going to be the biggest mistake maker. So you got to make sure that you push that negative through both. So if this helps, just take this and push it in the front, and then you can use it as a negative 2x instead of a positive 2x. And then you're actually using that negative. Okay? Any questions on that? Okay, and then all the other ones were exactly the same setup, just different numbers. So the different numbers do make a difference, because if I have my first is x plus 2, the derivative is just 1. The second is x squared minus 1, and the derivative of that is 2x. You can see it's basically the same setup. The only difference is now I have a number that I have to deal with. Okay, so we walk through the process, and I won't do all of these because we're running out of time. And then times, so the derivative of the first times the second minus the first times the derivative of the second, all over the second one squared. Okay, so it's a matter of just simplifying this top. So I could just do this real quick right up here. So negative 2x times x is a negative 2x squared. Negative 2x times 2 is a negative 4x. And then I can simplify it. So x squared minus 2x, there's my negative x squared. And then minus 4x minus 1, all over the x squared minus 1 squared. So room 1 and 2 had the same exact thing. Okay, yeah, and Adam, each room, then this was room 3, and so the slide was number 5. So it just depends on which slide you're on, or which room you were in, determined which slide you were on. Okay, so we have the first is x. Yeah, go ahead, George.
I did that one. I just have it on paper. My bad. I didn't write it
Okay.
on.
Okay, that's fine.
I got. Oh, do you want me to tell you the answer, or?
Yeah, go ahead.
I got negative x squared minus 2x minus 2 over x squared minus 2 to the power of 2.
Okay. All right. So where this came from, so 1 times this. So again, you're not going to have to change anything, right? 1 times this. And notice the way I'm multiplying. That's why I always set it up, I set up my forecast of characters the exact same way. 1 or the derivative of the first times the second minus the first times the derivative of the second, all over the second one squared. Okay, so again, I can do this real quick. I get negative 2x squared and then minus 2x. So that's where the negative x squared comes in, because we have negative 2x squared and x squared. We have a minus 2x and a minus 2. So perfect. Good. Okay, so I won't do the last one. Room 4, I think, was even different. Did I do room 4? Yeah. So room 4, What'd you guys get? Should be x squared minus 6x minus 1 over x squared minus 1 squared. Perfect. You guys did it perfectly. Good. Okay, so we're going to stop there. Just remember that it's all about which rule to use when. That's going to be the key to this chapter, is knowing which rule to use when, and it just takes practice is all. Okay, if you can get out of the product rule and the quotient rule, do it, because obviously it's a lot of work. But if you can't, make sure you know how to do it. All right, have a great weekend, you guys, and I will see you on Tuesday.
Miss Manchester,
Yes.